Okay, here we're in section 5.2, and we're going to be talking about arithmetic sequences and series. Some of the sequences that you've looked at so far were actually arithmetic, we just didn't call it that. So we're going to dive a little bit deeper into what an arithmetic sequence is. And first, we're going to go ahead and define some terms. So an arithmetic sequence is a sequence in which the difference between consecutive terms is the same, right? So the difference between each one is going to be the same. The difference between consecutive terms is the common difference. Is the common difference of the sequence. Okay, so because we're talking about a difference, that means that we're going to be adding something or we're going to be subtracting something. So we should see a pretty consistent change. All right, let's take a look at these. We're going to determine if it's arithmetic, so that would be a yes or a no. That's what I'm looking for. And then if it is, find the common difference. Now we use the letter D to represent the common difference. So you'll see if we find an arithmetic, I'll go ahead and say D equals, and that's why. My common difference is equal to D. So to go from 16 to 6, that means that I've gone down 10. From 6 to negative 4, also down 10. Negative 4 to negative 14, also down 10. So I can say, yes, this is arithmetic, and D is equal to negative 10. So when I have a value like this, it's really speaking to the difference between each of my terms. Okay, let's do another one here. So 4 to negative 196, the difference there. And go ahead and pause this video for a moment and see if you can figure this out. Okay, let's get back to it. So 4 to negative 196 is minus 200. To get from negative 196 to negative 396, also negative 200. To get from negative 396 to negative 596, also negative 200. So yes, this is arithmetic, and D is equal to minus 200. Now remember how we figured this out, because we're going to need this down in example 4 when we're writing our equations. All right, with C and D, see if you can go ahead and get these on your own. Pause the video and then check your answers. If your answers are correct, you can fast forward to the next section. If they're not correct, you want to make sure you rewind just enough to show how we do it. All right, let's take a look at C. From 2 to 4, I have plus 2. From 4 to 12, I have plus 8. So here I already have a problem. It's not the same. So it doesn't really matter what my difference between 12 and 48 are. I've already broken the rules. So I can say no, and there is no D to be able to describe because there's not a common difference. All right, let's take a look at part D. To get from 4 to 7, that's plus 3. 7 to 10, that's plus 3. And 10 to 13 is plus 3. So yes, I can say this is arithmetic and that my difference is equal to positive 3. Now, typically, if it's a positive number, we don't really write the positive. So occasionally you might see me write a number without the positive. It just means it's positive. Okay, so let's see what this girl Heather is up to. The bus schedule at a bus stop by Heather's house. Describe the pattern shown in the table and find the next 2 pickup times, assuming the pattern stays the same. Okay, so we have 5 pickup times, so we need the 6th one and the 7th one. Let's see if we can find a pattern. From 6:05 to 6:20, that's how much time? Yep, you got it, 15 minutes. And to get from 6:20 to 6:35, yep, another 15 minutes. How about 6:35 to 6:50? 15 minutes. And then 6:50 to 7:05, yep, 15 minutes. So I think it's pretty easy to say that I'm going to be able to figure out what the next thing is. So I'm going to, for part 6, I'm going to take that 7:05 and I'm going to add 15 to it. And that's going to give me 7:20, and of course this is a.m. So my answer for my 6th stop is going to be 7:20 a.m. And then I'm going to take that 7:20, and I'm going to add 15, and that's going to equal 7:35 a.m. So that's the answer to the second one. So what's interesting here is that this term is actually a to the n minus 1. It's the term before it. And this is actually what I did to it, right? So this is my difference that I have. It's really what I would call D, right? So that's my difference. So let's go ahead and look at the recursive formula for the arithmetic sequence. So essentially what we're doing, just to remind you of your recursive formula, it's a to the n equals a to the n minus 1, and then I'm going to say plus d. So if d is a negative number, then obviously it's going to be negative. Let's take a look at how these are. So I've got to find the difference between these. So 33 to negative 167, that is going to be a difference of negative 200. And then negative 167 to negative 367, again, minus 200. And negative 367 and negative 567, negative 200. So if I'm writing this, I want to first make sure that I say what my first term is, and I'll need that in the next example. So it's always a good practice to write that down. And then I'll have a to the n equals a to the n minus 1 minus 200. Excuse me. So did you see what I did up here? I took a to the n minus 1 and I added my difference there. So I actually used the recursive method to solve for example 2. All right, let's go ahead and take a look at example 4. We want the explicit formula. Well, we have a specific one here, okay? Sometimes you'll also see this as a1 plus d times n minus 1. It doesn't matter which way you do it. It's just you'll see it different ways depending on what book you're looking in. And when we get the equation, we're going to take that d and we're going to distribute it across n minus 1. So let's go ahead and do an example so you can see what I mean. Okay, to get from 12 to 8, we subtracted 4. To get from 8 to 4, we subtracted 4. To get from 4 to 0, we subtracted 4. So D is really negative 4. So A1 is going to be 12. So let's go ahead and get to my equation. So a to the n is equal to 12, which is my a1, plus, I'm going to go ahead and do it like this one. So I'm going to say n minus 1 times negative 4. So remember I said we're going to take that 4 and distribute it across n minus 1. So that's going to look like this. 12 plus negative 4n, negative 4n, and then we're going to have plus 4. Because when I take a negative 1 times a negative 4, those two negatives are going to make a positive. So don't forget all of your signs there. So I'm going to take my like terms and add them together. So I have a to the n equals 16 minus 4n. So that is my equation for this particular one. All right, let's say I wanted to find a of 32, okay? Knowing this new equation, I could say 16 minus 4 times 32. So as I'm going through that process, it's going to be equal to 16 minus 128. So that would give us an answer of negative 112. So the difference between an explicit formula and a recursive formula is I could pick any term that I wanted and I can find it with an explicit formula. I don't have to rely on my previous information. All right, let's go ahead and take a look at the next one. If you can, go ahead and stop the video. Just pause it, and I want you to see if you can figure this one out on your own. Once you're done, fast forward, and I'm going to have you actually solve for a to the 24. So if you have, go ahead and fast forward to that, check your answer. If you did not get the same answer I did, then go ahead and rewind and take a look at the explanation. All right, let's take a look at what we've got. From negative 22 to negative 20, I added 20. From negative 2 to 18, I added 20. From 18 to 38, I added 20. So my equation, oh, and I can't forget A1. So A1 is negative 22, and my D is equal to 20. So A to the N equals negative 22 plus N minus 1 times 20. So that's going to be negative 22 plus 20N minus 20. So that'll be negative 42 plus 20N. So that's going to be my formula. I've got that all ready to go. So now let's go ahead and solve for a to the 24. That should be negative 42 plus 20 times, 20. Let me get that right here. 20 times 24. So that's going to give me negative 42 plus 480, which gives me a value of 438. All right, let's go ahead and take a look at the last problem for this page. At the new Megaplex Cinema, there's 10 seats in the first row, 13 in the next row, 16 seats in the next row, in the third row. In general, 3 seats more in each row than the previous row. Find an explicit formula for the number of seats in the nth row. How many seats are in the 20th row? If the last row has 100 seats, how many rows are there? Okay, so that's 3 questions really that we're doing. Let's take a look at the explicit formula first. I know that the difference is going to be plus 3 each time. My A1, right, where it first starts, is going to be 10. So A to the N equals 10 plus N minus 1 times 3. So that's going to be 10 plus 3N minus 3. So that's going to be 7 plus 3N. So that should be my equation for determining what what row I'm in, okay? So the second one said we want to find out at the 20th row. So that's going to be A to the 20. So when I do A to the 20, I get 7 plus 3 times N, which is going to be 20, right? So that's going to be 7 plus 60. So A to the 20 is going to equal 67. That wasn't bad. And then now we need to know how many rows if we have 100 seats. So when we had A to the 20, that told us how many rows that we had. So I want to know if the last row, or this is how many seats, right? That A20 is how many seats I have. So if we know that's going to be 100 seats, that should equal 7 plus 3N. So I'm going to subtract 7 from both sides. So minus 7 and minus 7. So I should get 93 equals 3n. And then divide both of those by 3. And I get n equals 31. So 31 rows is what I get if I end up with 100 seats in the last row.